A bulbous bow is a hydrodynamically optimized protrusion located at the forward section of a vessel's hull, positioned just below the waterline. Its primary function is to alter the pressure distribution and flow field around the hull, inducing wave interference effects that reduce total resistance, particularly wave-making resistance. This results in improved service speed, operational range, fuel efficiency, and, to a lesser extent, longitudinal stability. In large vessels, the implementation of a bulbous bow can yield fuel efficiency improvements on the order of 12% to 15% compared to geometrically similar hulls without such a feature. Additionally, the increased volume at the bow enhances local buoyancy, contributing to a reduction in pitching motions. From a design and functional standpoint, the internal volume of the bulb is often sufficient to accommodate auxiliary systems such as bow thrusters and, in some configurations, sonar. A bow bulb is a key element in a ship's overall performance, playing a crucial role in reducing drag, optimizing energy consumption, and improving hydrodynamic efficiency. To obtain accurate digital representations of the bow bulb's actual, as-built, state, we rely on advanced laser scanning technologies capable of generating high-density point clouds with millimeter precision. From this data, we produce three-dimensional models that faithfully reflect the existing geometry, even in hard-to-reach interior areas or those with high structural complexity. This capability is particularly relevant for bow bulbs, where organic shapes and operational conditions make obtaining reliable data through traditional methods difficult. Scanning allows for the assessment of deformations or structural damage resulting from impacts, providing precise information for repair processes and technical decision-making. The generated models facilitate the integration of new equipment or systems within the hull bulb, ensuring a proper fit in geometrically complex environments. They are also a key tool in inspection tasks, enabling the identification of phenomena such as corrosion, wear, or thickness loss with a high degree of detail in